Hello my friends and welcome to this new practical activity, the first one of part 6, reinforcement learning, where we will be implementing the UCB algorithm, upper confidence bound. It is one of the most exciting branches of machine learning because it is the closest to artificial intelligence in the sense that we're making some programs that play some actions just like a robot. So this is very exciting. This is one of my favorite branches, if not the number one. And so I'm so excited right now to teach you about the fundamentals of reinforcement learning, and especially I'm so excited to implement two of the best reinforcement learning models with you, which are UCB and Thompson sampling. So first in this section we will implement UCB, upper confidence bound, and once again we will apply it on a business case study, which will be the next part of the story we had in part 3, classification. You remember that SUV, that brand new luxury SUV that this car company was trying to optimize the targeting thanks to classification? Well, this time we're going to optimize the online advertising, meaning that we're going to find the best ad, among different ads designs, the best ad that will convert the maximum customers to click on the ad and, potentially buy the product, buy the car, okay? So I will explain the story a bit more later, but before, let's just make sure everyone here is on this same page. I gave you the links to this whole folder right before this tutorial in the article, so make sure to click it. And now we should all be on the same page, so let's do this. Let's enter part 6, reinforcement learning. And we're going to start, as we said, with upper confidence bound, UCB. And so this time you not only see the two folders Python and R, but you also see the full slide of the UCB algorithm. And you will also see the full slide of the Thompson sampling algorithm in the other folder. So let's have a look at it. Make sure to download it. And if you want, you can print it and post it on your wall. There you go. You have the 3 steps of the UCB algorithm, which we are going to implement together. I will actually give you a lot of exercises in this implementation. I will tell you before we implement each of the steps to implement it yourself. So at first you will have to implement step 1. Then once step 1 is implemented, we will implement step 2. You will do it first before we do it together, and then step 3. So you see, it will be a very learn by doing process. All right, so that's the slide. Make sure to download it. And now let's go into Python first to implement the UCB algorithm. All right, so as usual, you have 2 files here. You have the dataset, add CTR optimization. CTR means click-through rate, and that's what we're going to optimize thanks to upper confidence bound first and then Thompson sampling. And then we have the implementation, of course, upper confidence bound in the IPYNB format, which you can open with either Google Colaboratory or Jupyter Notebook. All right, so as usual, let's start by explaining what this dataset is about. So as I said, we are doing the next part of the story of this car dealership trying to sell that new SUV. We've already done the targeting, we've already optimized the targeting thanks to classification in part 3. And now we're going to optimize the click-through rate of some ads we're going to make for this car. Okay? So what happened exactly is that the advertising team prepared 10 different ads, with 10 different designs. For example, on one ad, we will see the SUV in a beautiful mountain. On the other ad, we will see the SUV in a futuristic city. On another ad, we will see the SUV in a charming city, like a charming city in the south of France or Italy. On another ad, we will see the car on the moon. Why not? On another ad, we'll see the car on a beautiful countryside cornfield, something like that. So basically, all the ads have different designs, and the advertising team is wondering, well, which ad will convert the most? Which ad will attract the most people to click the ad and then potentially buy the SUV. So we have these 10 different ads, and what we're going to do, and that is the process of online learning, we're going to show these ads to different users online, once they connect to a certain website or to a search engine. It can be the ads that appear at the top of a page when you type a research on Google. We're going to show one of these ads each time the user connects to the web page, and we're going to record the result, whether this user clicked yes or no on the ad. Okay, so just to recap, there is a first user that connects to, let's say, a web page. Our algorithm, which will be here first, UCB, will select an ad to show to this user, and then the user will decide to click yes or no on the ad. If the user clicks on the ad, we will record it as 1, and if the user doesn't click on the ad, we will record it as 0. Okay? And then a new user connects to the web page, and same, the algorithm selects an ad to show to this new user, and if this new user clicks the ad, then it's a 1, and if not, it's a 0. Okay? And we're going to do this for lots of users, actually 10,000 users. And that's what this dataset is about. However, now there is something you must absolutely understand, and that is very, very important. Make sure to understand it and make sure to rewind if this is not understood, okay? So I'm going to explain this. Please listen carefully. So, in reality, what happens is that users connect one by one to the web page, and for each of them, we successively show them the ad, right? So everything happens in real time. It's a dynamic process. It's not a static process with a static data set which was recorded over a certain period of time. It's a real-time process. And therefore, the only way to simulate this would be either that I, make 10 real ads right now, 10 real ads of a car, then I open a Google AdWords account, and then I show the ads for real to some users, real persons connecting to the website. Of course, I'm not going to do this because, first of all, this is costly, and then, this would deceive the users. Well, I would have to really sell a car somehow. So, of course, this is not an option, and therefore, I have to make a simulation. Okay, I have to make a simulation, and this simulation is exactly given by this dataset. Because in this dataset, what happens is that each row corresponds to the different users connecting to the web page and to whom we're going to show the ads, and then each column of this dataset corresponds to the different ads, okay, from ad 1 to ad 10. And this dataset is a simulation in the sense that each time a user connects to the web page, well, this dataset tells us, even if we wouldn't know in reality, this dataset tells us on which ad the user of the row would click on, So, for example, this first user, this corresponds to the first user to whom we're going to show the ad. And what these cells mean is that this user would click on ad 1 if we show this user ad 1, then it wouldn't click ad 2 if we show ad 2, because there is a 0 here, then the user wouldn't click ad 3 if we show ad 3, it wouldn't click ad 4 if we show ad 4, but then it would click ad 5 if we showed ad 5, and etc. So in other words, we know, thanks to this simulation, this dataset doing a simulation, we know that this user would only click ad 1, ad 5, and ad 9 if we showed these ads. And then if we showed all of the other ads, ad 2, ad 3, etc. up to ad 8 and ad 10, well, this user wouldn't click the ad. Now, I know we wouldn't know that in reality, but that's why I'm saying that this dataset is a simulation. And this is the only way we can actually run the UCB algorithm or the Thompson sampling algorithm if not doing it for real, with a real advertising campaign. Okay, so I hope it's clear. Please rewind if it's not clear, because I think I've said all the keywords. This dataset is a simulation. Therefore, for all the users, corresponding to these rows, we know on which ad the users will click, right? This user, for example, would click only on ad number 2 or ad number 8, right? But wouldn't click on all the other ads. And so that's the only way we can indeed simulate the Thompson sampling or UCB algorithm. All right, so I hope it's clear. Then we have, let's scroll down to the bottom. We have in total 10,000 users, as we said. And so we're going to run the UCB algorithm first and then the Thompson sampling algorithm to figure out the ad that has the highest conversion rate, right? The ad on which the users click the most. So I know that we could do it, for example, with a naive strategy, a naive algorithm, like a simple one where we collect some simple statistics to see which ad is most frequently clicked on. But remember, as Kirill explained in the intuition lectures, each time we impress an ad, on the website or the Google search engine, well, this incurs a cost, right? It has a cost to impress ads. Therefore, we need to figure out as fast as possible, in the minimum number of rounds, because, the users here are represented as rounds because we show the ads to the users one by one, as in one round after the other. So we need to figure out in a minimum number of rounds which ad converts the most, meaning which is the best ad to which the users are most attracted to. And that's why we need a stronger algorithm than a simple statistics algorithm, and that stronger algorithm will be first UCB and then Thompson sampling. And we will even see which of the two is the most powerful. All right, so I think that's enough explained for this dataset. Now we're going to start the implementation. I can't wait. This is a very exciting and actually widely used algorithm in online advertising or digital marketing. So let's do this. Let's click this implementation and then let's open it with Google Collaboratory. or Jupyter Notebook as you want. All right, so now it is loading it. It is loading the notebook, laying out the notebook, and now here you go. Welcome to the UCB implementation. All right, so as usual, we're going to create a copy because this is in read-only mode. So in order to re-implement this from scratch, we're going to click File here and then save a copy in Drive. This will create a copy inside which we will be able to re-implement the whole algorithm from scratch. All right, so it is opening. You notice that I have my data preprocessing template opened. That's because we will use it very quickly, just to actually import the libraries and the data set. And so now, before we start, let's delete all the code cells here, but not the text cells. And very soon we should be able to start. Okay, so that's a simple implementation, a simple structure, but this cell will actually be long, and that's where you will practice by doing first some steps of the implementation before we do it together. And so let's have a look. Welcome to the UCB implementation. We will start first by importing the libraries, then we will import the dataset, then we will implement the full UCB algorithm just following the steps on the slide, with the 3 steps. And finally, we will visualize the results, and by that I mean that we will plot a histogram where we will clearly see the ad that was the most selected. And that's of course the ad that was identified as the strongest ad, the most attractive ad for the users. And one thing I forgot to say, and which is really, really important, this data set actually supposes that each ad has a fixed conversion rate. So ad number 1 has a certain conversion rate, ad number 2 has another conversion rate, and then same for all the other ads. And that's of course because it is a required assumption of both the UCB and Thompson sampling algorithm, basically reinforcement learning algorithms for online learning. And that's, anyway, the case in reality. For example, with the slot machines in the casino, well, they all have a fixed conversion rate, unless they change it over time, but that's another question. But there you go. Usually, an ad that you show online has a fixed conversion rate because it will convert over time the same rate of people. So we will assume this, and besides it's close to reality, but there you go, that's an important assumption of online learning. All right, so now we're ready. We're ready to begin this implementation. I hope you're excited. I hope you understood this data set and the fact that we're doing a simulation because we actually don't have too much of a choice. And so if everything is all good, well, my friends, let's begin this implementation in the next tutorial. And until then, enjoy machine learning.